and 2 is C, then D. Okay. So first thing I'm going to do is I'm going to look for not A if and only if B, and I don't see it. Okay. So the second thing I'm going to do, notice I keep thinking about this the same way, is I'm going to look for its opposite, and the opposite would be A if and only if B in the antecedent of a conditional. Look for that, because if I can find a not box, then I can do modus tollens and get what I need. Okay, so I'm going to look for this arrangement. There it is, right there. Okay, to do the modus tollens, I need the opposite of not C then D, which would be C then D. And there it is. So I can do a modus tollens on 1 and 2, and that gets me not A if and only if B, 1, 2, modus tollens. Okay? And so look, these problems, these steps, they are easy, right? So when you do these more complicated problems, it's just one easy step after another. It's just that you gotta stack a whole bunch on top of each other. 9. Okay, this is the first problem that might involve some thinking. We have to get to not C. We have A, then not B. 2 is A. And 3 is C, then B. Okay, I have to get to not C. So the first thing I look for is a not C. I don't see it in my premises. So the second thing I'm going to look for is the opposite of it. So that would be C, and the antecedent of a conditional. Because if I can find not box, then I can get to not C by modus tollens. So let me see, do I have a C then blank? I do, C then blank. Now, to get a C from line 3, I would need a not B. So let me look for a not B. Well, there's a not B, but it's not free and clear because it's part of a conditional. It says not B is true only if you can go find me an A. It says if A, then not B. So now I'm looking for an A, damn it. Oh, there it is. Okay, and now I'm just going to follow that mental path backwards. So the first thing I'm going to do is step 1 and 2. This says if A, then not B, and I have an A. So I can say not B from 1 and 2 modus ponens. Okay, now I have to remind myself, why did I get the not B? Because I wanted to get a not C from line 3. And so once I have deduced a line, I can use it, okay? Because I now know that it's true. And so if you look at 3 and 4, I can say not C, 3, 4, modus tollens. And I'm done. Everybody got that, okay? A couple things to say. I don't know if I'm repeating myself because it's all blends together, and that is this. As we get towards the end of the section, I think there's 70 problems in this section, and then we have another section that we have to learn, stuff like that. The problems at the very end of the section are going to be pretty hard. You might not be able to do them. Fear not. If you can get 2/3 of the way through the problems because they increase in difficulty, you're good for the test. Does everybody understand that? I don't need you to be some whiz at this, some savant at this. I just need to know that you are competent and capable, that you understand this at a basic level. Does everybody understand that? So don't freak out when you get to these big old monster problems and you're like, oh, I don't know how to do this, okay? The test problems will not be as hard as the hardest homework questions, okay? Oh, and also, as you go to prepare for a test, you might say, well, let me keep doing new problems, new problems, new problems. That's actually not the best preparation. The best preparation is sometimes going over and redoing problems that you've solved before, because then you start getting into this pattern recognition. And solving these is all about pattern recognition. Does everybody understand that? It's kind of like playing chess. I mean, some of those chess players, they played so many games that in the opening, they don't need to think because they've seen it before, right? And they might rattle off their first 12 to 15 moves without having to think. And if they're thinking, it's only about, well, what kind of end game do I want to play? Not that, oh, if I take this, like that. No, they're not even thinking that, right? Okay. Number what? 11. Number 11, prove not C or D. Number 1 says A, then not B. 2 says C or D, then A. 3 says B. And by the way, when I'm writing these up on the board, I can possibly make a mistake transferring it from the text to the board. Don't let me do that. You know, if I miss a negation sign or I replace an and with an or something like that, that can make the problem invalid, which would mean it's not solvable, and that would waste us a lot of time. Okay? Okay. All right. So first things first, I want to prove one of these. So I look for it, not C or D. Can't find it, not in my premises. Okay? So the second thing I look for is its opposite, and the opposite of this would be C or D in the antecedent of a conditional, because if I can find not the consequent, I get what I need by modus tollens. So let me see if I can find this. C or D, then blank. There it is, right here. Okay? To get not C or D from this, I need the opposite of the consequent. I need a not box. So I need a not A. Let's look for a not A. I don't see a not A, damn it. So think about the algorithm, right? If I can't find what I need, I look for its opposite in an antecedent. I needed a not A, so I'm looking for its opposite, which would be an A in an antecedent. There it is. I can get a not A from here if I can get a not B, which is a what? B. And look what's hanging out on line 3. How convenient. All right? So that's our first step, and then we're just going to follow that thought process backwards. So look, A then not B, but not B gets us not A from 1 and 3 modus tollens. Now we got to remember why we got the not A, because we wanted to use it on line 2. It says blah, 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 then A, but we don't have A, so we must not have that. So we get not C or D from 2 and 4, and this is modus tollens again. So yes, you can reuse rules. Does everybody understand that? And you can use a premise more than once. And once you've concluded something like this, you can use it to conclude other things. Everybody got this? So, simple. Okay, now 13, and you will notice this as these problems progress. I introduce one rule, and there's kind of like 3 or 4 or 5 problems that revolve around that rule. And then all of a sudden, let's add a new rule to the mix. And then a new rule to the mix. So if you ever get stuck, think, oh, what rules have I been using, and what rule do I have, what rule of inference do I have that I haven't used yet? Because chances are what I did is just switched modes and said, okay, now let's work on some problems that introduce this. Everybody got that? Okay. And at the end, it's just a free fall. So 13, B then A, and we have B then not C then D, and we have not C then D then A. Okay, so I'm going to think about this how I always do. I'm going to look for this, don't have it. I'm going to look for its opposite and an antecedent. I don't have that either. So now I'm on step 3 of my algorithm, as it were. Are there any computer science people in here? No one? So this is just like calling the same procedure over and over in computer science. This is like a recursive program that allows me to solve these problems the way I'm thinking about it. But anyways, so since I exhausted my first 2 strategies, now I look at what the operator is to figure out what direction I might go. And since it's a conditional, I realize that one of the ways I have of making a conditional that doesn't exist is this. Go find this, B then blank, and blank then A, because I can snap those together to B then A by the rule hypothetical syllogism. So I'm going to go look and see if I have those 2 pieces, those 2 building blocks. Okay? B then A. Do I have a B then blank? B then blank. Okay. Do I have a blank then A? Blank then A. Do those blanks match? Are they the same thing? Yes, they are. So I can do my hypothetical syllogism. It's like I'm cutting out the middleman. Okay? And so I get B then A from 1 and 2 hypothetical syllogism. So it's like this. I'm getting rid of this middleman. This, then that, and that, and this. Let's skip that middle step. Everybody got that? Okay. 15. Where's, can everybody see that 15 is just a 1-step hypothetical syllogism? It's just that the order of the premises are kind of reversed, and that's to remind you that they, you can mentally reverse them. Everybody got that? Okay, so let me push on